Hello everyone, my name is Jiang Shu and I come from the Photonics Research Lab. Today my topic is the integrated passive device measurement technique. That's the fifth chapter of the Professor Kim's book. And first I will give the introduction about integrated passive device and the measurement technique. Then we can have a little understand about them. Next, the on-wafer measurement will be shown. First, I will show the components of the microwave on-wafer test system, and later the calibration also will be shown. The last two part is the power handling measurement and process control monitoring. Then I prepared a summary about my presentation. Okay, the first part is the is the integrated passive device. The thin film integrated passive device have developed to replace the discrete passive components. Of course, there are many advantages of the IPD. For example, the low cost, small size, and increased performance. The second one is the passive device are totally integrated and mounted onto semiconducting substrate, and IPD transforms circuit using RLC chips into ICs that are much smaller and more precise. As shown here, for in this picture is the discrete passive solution, and this one is the IPD. So we can see the IPD part, the IPD case. The IPD case have a smaller size compared with the discrete passive case. So that's why the IPD have an important place in the circuit integrated circuit field. And here, in order to measure the overall performance of an IPD, all of the necessary components related to the IPDS must be accurately measured. Here is a requirement. The measurement should be based on the component level. The functions of measurement or the motivation we can see here is it can check the target specifications of the designed circuit and change variations of the parameter tolerations due to the process variations, and extract the accurate empirical models from the measurements. Here I will show the three parts of the measurement. One is the on-wafer measurement, and the second is power handling measurement. The last one is the processing control monitoring. So the first kind of the measurement is on wafer measurement. The advantage of it is the lower cost and greater accuracy, faster test time, and the last one is it's not required to bond or package the device before testing. The on-wafer measurement system consists of many different components. For example, the network analyzer, the RF cable, and RF prober. First, I will explain what's the network analyzer and its function in the on-wafer measurement system. It is used to characterize the device under test in frequency domain by connecting the source generated by the network analyzer to the input of DOT and the DOT output to the input of the network analyzer. So the result as shown in the figure B. In the figure B, the horizontal axis can show the frequency phase group delay, real part of the imaginary part of the transfer function. About the spectrum analyzer, it may be used to measure the amplitude and frequency of a signal spectral line. When the noise level is greater than the noise level of the spectrum analyzer, then it can be measured. About the prober station. The prober station can help us to understand the role of a RF prober in the test system. Here I show the part, the figure about the prober station. In the library, the chalk movements and DOT measurement are manual operations, and the computer automates on the manufacturing line. Before use the prober station, it needs to set on a vibration dampening table. Here is the use of the prober station. First, it should be put the wafer on a chalk, and a vacuum line runs through the prober station to the center of chalk. The motion adjusts the chalk height, and last the probers are fixed to the micro positioners circuit to the prober station. About the RF cable. The RF cable connects the test system to the DOT. Quality RF cables exist the minimal insertion loss and voltage standing wave region. There are two different types of the cable. One is the semi-rigid. It has a solid silver or copper jacket over the semi-flexible dielectrode protecting the solid conductor. Another one is the flexible cable. It uses a more complicated arrangement of the practical encased. Here I also show the law of use. We need to remember, bent the cables will dent the dielectrode and degrade the S parameter. Repeatability to no better than minor 40 dB. Changes in the environment cause change in the cable's phase delay. So the two laws is very important. We should remember when we use. This part is the RF connector and adapter and the probe. The connector and the adapter have many tips. Each one designed for a specific purpose and applications. For the measurement applications, it's important to consider the number of connectors or disconnectors, which impact the lifespan of the connector in use. And here, we need to keep the surface clean and use connector net carefully. About the prober, it can form a connecting between the coaxial cable and the prober pad. Here I show the RF prober tips. About the calibration, before an accurate measurement can be made, the test system should be first calibrated. It's the key factor whether our measurement can be succeed. So remember to calibrate your system before measurement. There are three different methods to calibrate our system. The first one is SOLT, second is TRL, and last one is LRM. Here I show the method in the figure and also in the table. For example, the SOLT, it's the most common used in the practical system, and TRL no fixed prober, but for the LRM, it can used with fixed probers. So you can choose them based on your situation. About the power handling measurement, here, when we talk about the power handling, that means the power level beyond which damage occurs usually well beyond the dynamic range of a system. The capacity of the power handling is a very important factor in the power divider and LPF. Here I show an illustration about the measurement system for the power handling. Here is an example about the result of power handling. Here's the power divider on this substrate endured up to 12 watt of incident power during the 6 hours step test. But this substrate have a very good thermal conductivity. The last method about the measurement is the process control monitoring. It can obtain detailed information in the integrated circuit. The PCM data is collected and analyzed. The wafer are deemed good if the data meets the predetermined specifications. In this picture, 5 PCM are used and located at the top, bottom, left, right, and center of the wafer. But there are some challenges of the PCM testing. For example, the long test time and accuracy of the instruments and calibrations, so that needs more time to use it very good. There's a summary about my presentation today. The PDM, so as I have showed, due to the IPD have many advantages, so it has very important place in the integrated circuit field. The second one, the IPD measurement technique can provide a designer feedback and help them to manage the overall performance of an IPD. On the wafer measurement system, consists many different components. For example, the network analyzer, spectrum analyzer, and RF prober. About the power handling, when it comes, that means the power level beyond which damage occur. So usually well beyond the dynamic range of a system. The process control monitor can obtain the detailed information in the integrated circuit, but as I have showed here, there are still some challenges to use PCM testing. That's all. Thank you.